My name is Melvin. Today I'm going to present on a topic called FlexRay. It is actually a bus protocol which is being used in the automotive vehicles. Uh, so before knowing more about FlexRay, let's know some of the basics of FlexRay. Like before FlexRay, what all protocols had been there. Uh, So before FlexRay CAN protocol was the one which has been used in the automotive industry. It was developed by the Bosch, and then came the LIN protocol, which was developed for less demanding applications in terms of communication speed and latency. And then came the MOS protocol, which satisfies the high data rates needed for multimedia applications. And then came finally the FlexRay. The FlexRay has been especially developed by FlexRay Consortium since 2000 for safety-related applications in the automotive industry. The core members of the FlexRay Consortium is BMW, Bosch, Daimler, Freescale, General Motors, NXP, Volkswagen. Uh, Main properties of FlexRay is 10 megabytes per second, deterministic, it is having deterministic behavior and static and dynamic bandwidth allocation, and it can be customized to different applications. So why do we use FlexRay? Is that it uses the X by wire technique, steer by wire technique, and brake by wire technique. Uh, the hydraulic steering and braking system is being replaced by the electronic ECU with sensors and actuators in this protocol, and the CAN is not supported by real-time capabilities because of the arbitration method. So, and then we look into the features of FlexRay. It is having a high-speed data rate. It is up to 10 megabytes per second with full duplex network communication, and then more topology support. It supports passive bus, active star, and hybrid topology instead of bus topology in the CAN protocol. And when we look into the bus operation, the bus operates time cycles as a static segment and dynamic segment. Then real-time communication, like arbitration technology in CAN, in FlexRay, the TDMA technology is used for real-time communication. And then in communication traffic, the FlexRay can work in both the half duplex and full duplex communication methods. Then serial type, it can work in both synchronous and asynchronous frame transfer. And then in latency, it guarantees the frame latency and jitter during the synchronous data transfer. Then in frame priority, it can prioritize frames during the synchronous data transfer. Then synchronization, the FlexRay has multi-master clock synchronization ability. And in error and signaling, it has also error detection and signaling ability like CAN protocol. Then when we look into topologies, as mentioned earlier, it has three topologies mainly: bus topology, star topology, and hybrid topology. In bus topology, it is a normal bus topology, same as the CAN bus. In this topology, a single node can be connected to one or more channels at a time. It is shown as in the figure, where two nodes are connected to two channels, and where node 3 is connected to a third channel, to one channel. And then when you look into star topology, it is like a closed ring. Any signal will receive by any node, any signal received by one node, and it will be sent to other nodes also. A signal node can be connected to a maximum of two star couplers only. And then about the hybrid technology. The hybrid technology is a combination of bus as well as star topology. Then when you look into the Communication cycle. A cycle comprises of static segment, dynamic segment, and the network idle time. Each cycle has a sign configurable duration. Then let's look into the static segment. Okay, in static segment, it has different nodes where different slots are available for different nodes, and each node owns one slot. And when through transmission of data, it should transmit only through the node or the slot owned by the node. Okay, and then a single slot has a fixed length of time and an identifier that is assigned to a specific control unit, and the second is having guaranteed latency for its hard real-time interface feature. The static segment has no delays and collisions. A single node can be allocated to multiple slots by its slot identifier. A very good example for static segment is airbag deployment that needs hard real time. So, and then next we'll look into dynamic segment. Uh, Dynamic segment is the second segment of FlexRay communication cycle. Each dynamic segment is also having a multiple numbers of slots, each slot having a unique identifier, and if any event will occur and will match with the corresponding slots identifier of that controlling unit, then it will allow sending data for that node. If it has a longer message that has to be sent in same cycle, then the next node time plot should move backward. The best example for this uh, dynamic segment is a Viper application which is used in the vehicles. Uh, then about the network idle time. The purpose of a network idle time is to synchronize the clocks. Then it will schedule each slot defined in the static segment, each slot corresponding to a data frame with a defined node. A frame can hold up to 254 bytes of data. Next, we'll look into the FlexRay frame format, where the FlexRay frame format comprises of three segments: head, header segment, payload segment, and then the trailer segment. The header segment comprises of 40 bits or 5 bytes, whereas payload segment comprises of 254 bytes, and trailer segment comprises of 24 bits. The header segment is again being subdivided into control field, frame ID, payload length, header CRC, and cycle count, where the control signal is the first field in each data frame. It is having 5-bit fields. Each bit is having a control signal status for the start of a new data frame sent. These are reserved bit, payload frameable indicator, null frame indicator, and the sync frame indicator, and the startup frame indicator. And followed by uh, control signal is the frame ID. It is nothing but a unique identifier for each FlexRay data frame, the same as a CAN identifier. And then comes the payload length. It is a third field, and it is a 7-bit field that defines how many bytes of data are getting transmitted in that corresponding data frame. It is same as the DLC field of the CAN protocol. And followed by the payload is the header CRC. The header CRC is the fourth field, and it is 11-bit CRC data. It is used to validate the valid data on the receiver side. The header CRC calculated by using the polynomial method. Then to calculate the CRC, it will take the input as null frame indicator, sync frame indicator, and frame identifier, and payload length. Then comes cycle count. Cycle count, its main objective is to keep in track the number of cycles that has been sent and that has been operated. Then comes payload segment. Payload segment is nothing but the data field of FlexRay data frame. It can have from 0 to 254 bytes of data, whereas in CAN protocol it is having somewhat 8 bytes of data. and in KMFT it is having 64 bytes of data. And then when you look into trailer segment, uh, in trailer segment it is third and last section of the FlexRay data frame. It is 3 byte or 24 bits of CRC trailer. It is calculated over the payload and header sections of the data frame. This mostly used by the receiving node for second time to confine the successful receiving of the data frame without any error. Then about the clock synchronization. Uh, when you look into the clock synchronization, each node has its own clock. Each node measures the time difference between the expected and the observed arrival time of all sync uh, of all sync frames based on the measured time deviations. Each node calculates and applies a clock correction term, and all nodes synchronize to all sync nodes. The main objective of uh, clock synchronization is to synchronize all the clocks. Okay. Then when we look into message flow in a FlexRay, it comprises of FlexRay host controller, a FlexRay communication controller, and FlexRay transceiver or a receiver, and a bus guardian. Uh, when you look into the FlexRay host controller, the main objective of this module is to run the application software as per the requirement. It will send or receive the data to or from the FlexRay communication controller. It is also used to control the different operating modes or power control of FlexRay communication controller and transceiver or driver module. Then comes the FlexRay communication controller, which comprises of controller host interface and a buffer and a protocol engine. In FlexRay communication controller, it is used to interface the FlexRay bus data with the host controller and also the transmission and reception of the message processing. It is also used for clock synchronization. When we look in particular the CHI, the controller host interface, it is used to interface between the host and the controller to control the command and message interface. It is also responsible to handle the configuration and status data, to handle the message buffers for transmission and reception of data frames also. Then comes protocol engine. The main objective of this module is to host commands and protocol conditions as per the application software. It is also responsible to control or change the different operation modes of core processors. Later in next slide, I'll be discussing about the different operation modes also. Then it is having a transceiver and a receiver. Next, the FlexRay protocol operating modes. Uh, in like CAN or the other protocols, FlexRay protocol is also operating in different modes. These modes are defined in power consumption and proper operation of FlexRay protocol. In FlexRay network, in FlexRay it is called as protocol operation control or as POC. This POC process sets operating modes of frame and symbol processing for each communication channel. It has three operating modes as mentioned below. Uh, the three are standby mode, startup mode, and run-up mode. The standby mode is used to halt the execution of the frame and symbol processing processes. And then comes the startup mode. This mode is used to start the execution of the frame and symbol processing processes. And in this mode, in this mode it will run the execution of frame and symbol processing process, including the CHI update, which also will take place. I hope this this information would be helpful to you guys. That's all about FlexRay. And thank you.